So today I'm going to be talking about the TCP/IP layer model. So essentially, what this layer model is it's splitting networks into layers, and each layer has a different set of protocols. And every single layer is basically self-contained, and it's only going to interact with the layer above and below. And from an engineering standpoint, this is really nice because you can have people who really specialize in the application layer, so working with websites and web development, and they don't have to know crap about how the physical stuff works, how it's data is being transmitted using signals, or how you're using cables and all that good stuff. But essentially, whenever you are sending or receiving data from somewhere else, you're going to be moving up and down this stack. So if I want to send data to somewhere else, I'm going to be moving down this stack, and this is called encapsulation, because at each layer you're going to be adding another protocol. And then when you are receiving data, you are going to move, the data is going to move up the stack to you, and this is called decapsulation. Now, how's this working at each layer? So the application layer is all about different individual application programs. So right now you're actually using the application layer because you're watching this on YouTube, and this has to do it's all about HTTP, or HTTPS is the secure version, and this is where your data is going to be produced. So then you're going to go to the transport layer, and this is all about program to program, such as TCP or the UDP protocols. And essentially you're taking, this is telling you how do I want to transmit my data. So I have a block of data. Say I'm actually going to send this, and I'm going to segment it. And TCP or UDP is going to tell me how I want it to be transmitted. So if I want to use TCP, then I'm saying that I want every single piece of data to get to my receiver. And say even if one piece of data is lost, well, I'm going to resend it because it really matters to me that this is sent as a chunk, and I'm willing to sacrifice speed. Whereas UDP, if a little chunk of data is lost, that's fine. I don't care. I'm not going to resend it because I really care about it getting to them as fast as possible. And TCP is actually going to be more popular than UDP, but UDP is still useful because say you're using Zoom, you really care about your information being you really care about it being timely, right? So if you're talking to your friend, it's better that you can be hello, how are you, and they can respond instantly, than them lagging for 10 seconds, even though you're able to get the full information. Because say it glitches out and you can't hear them, you can just say, oh hey, can you repeat that? And so the way that you're communicating between programs is ports, and you're gonna have a source and destination port, and that's just going to identify applications or websites. Okay, so the internet layer is going to be where you're adding your IP addresses. And your IP addresses essentially just specify or uniquely identify different machines. So every single device connected to the internet has a specific IP address. So your smartwatch, your phone, your laptop, they're all going to have a specific IP address. And so you, for every single packet of data, they're going to add like your IP address and the IP address that you're trying to send it to. And there's different versions of IP. So there's like IP version 4, there's IP version 6. IP version 6 is actually it's newer and it just adds more digits, so we're not running out of space on the internet. Not super important, but just fun to know. The network interface level layer is all about like your local area network. And so this is like your Ethernet, which your Ethernet is like allowing devices to connect to your local area network. And then the physical layer is just like all the hardware, so like your cables, like the network interface cards. So let's sort of think of an analogy for this. I like to think about like the puzzle piece analogy. So say you have like a puzzle and you completed it and you want to send it to your friend. Well, you are going to take it to the post office, and the post office is going to be like, hey, this puzzle is way too big. Let's break it into a bunch of different chunks. And so this is your transport layer. They've broken it into chunks, and they're going to say, hey, how do you want this sent? Do you care if she gets every single piece of the puzzle? If so, that's going to be TCP. Otherwise, you're going to use UDP. And then the post office is going to take every single puzzle piece, and they're going to stamp it. So they're going to say, we're going to stamp it with your address and then your friend's address. That way we know how to deliver it. And then the last bit of this has all to do with like transportation. And so they're going to like put it in some truck. And the truck is going to be made up of like a lot of physical hardware, like wheels and whatnot. And you're going to use like Wi-Fi or like Ethernet in order to send it to your friend. And then your friend is basically going to do the reverse process. So it's going to get all of these pieces, work backwards, and they are going to get the full puzzle piece. Or the full puzzle. That's a puzzle, pretend. So yeah, that's the TCP and IP layer model.